So here in section 7.5, we're going to look at determining sample size. So in a designed experiment, you can actually choose the sample size to control the reliability of your interval estimate. And what we know is that a larger sample will increase reliability. And that's because sigma x bar, the standard error of the x bar distribution, and sigma p hat decrease as sample size increases. So let's look first at the sampling error in a 1 minus alpha 100% confidence interval. The sampling error is just the half width of the interval. So here's that confidence interval goes from mu to mu plus z alpha over 2 sigma x bar to minus z alpha over 2 sigma x bar. So now when we are doing sample size estimates, we use z instead of t here because we don't know about the distribution for the data that we're looking at. So in that case, we always use z. So the sampling error is right here. It's the half width of the interval. This is the confidence interval. So notice that as n increases here, the sampling error decreases because the square root of n is in the denominator. Bigger denominator, smaller fraction. So to determine the sample size, in this case, what we do is we take the sampling error, which is z alpha over 2 sigma over root n, or if we don't know sigma, we can use s in there. And then we solve this expression for n. So if we solve that for n, we get z alpha over 2 squared, sigma squared over the sampling error squared, or same thing with s squared. And then notice here that s can be approximated by the range divided by 4 if sigma is not known. So we can always get an approximation for s. So we want to estimate here the mean time that it takes for a pain medication to take effect to within 5 minutes. So that's going to be our margin of error, sampling error. So SE here is going to be 5. The medication's administered to a sample of 30 individuals, and the sample mean to take effect was 38 minutes with a sample standard deviation of 5.5. So our sample mean was x bar equals 38. That's actually not used in the formula. And then our sample standard deviation was 5.5. How large? How large must the sample size be to get the desired estimate with 99% confidence? So let's go ahead and bring our sample size formula down here. So z alpha over 2 for 99% confidence, that we can get from the confidence interval table. So that is this table from section 7.4. So we see the z alpha over 2 that goes with 99% confidence is 2.575. So this will be 2.575. That gets squared times our 5.5 squared. And then we're dividing by the sampling error or the margin of error squared, which is the 5. And if you enter this into the calculator, you get 8.02, and we always round sample size up. So this would round up to 9, because 8 would not be quite big enough to get that sampling error or margin of error of 5. So we always round up for sample size.